Hello everyone, welcome to Big Data Thoughts. Today we are going to talk about Snowflake. This is data warehouse on cloud and it has picked up a lot in the market in the last couple of years and people are using it extensively. So we are going to talk about what is Snowflake, what are the features that it provides, what kind of an architecture does it have. So let's get started. First of all, what is Snowflake? At a very high level, we would say Snowflake is a data warehouse which is offered as a SaaS application, a software as a service over cloud. So it's a data warehouse over cloud which you can use as a SaaS, or we can call it as an enterprise analytics database. It fulfills all our needs of bringing in data from different sources, running SQL on top of that, doing analytics, or treating it as a data warehouse on cloud. So why do we say that Snowflake is SaaS? The most important thing here is that there is no hardware installation, configuration or management that we need to do. Because it's a SaaS or software as a service, it is provided on all the major cloud vendors like Amazon, Google, Azure. We can operate or we can use Snowflake as a software as a service. So there is no software to install because it is coming out of the box to be used as a service. There are no overheads of having any kind of physical virtual hardware to be configured, managed or set up, no software to be installed or configured. There is no ongoing maintenance in terms of upgrades or tuning. Everything is handled by Snowflake. Now, one thing, Snowflake cannot be run on a private cloud infrastructure or on-premise or hosted. It is a publicly available, or on public cloud it is available as a software as service. So it is not a packaged software offering. It is a software as a service offering, which makes our life pretty easy in terms of just using and paying for what we are using. Now, when we looked at what at a high level Snowflake is, it's a data warehouse. But how does the architecture of Snowflake look like, or what it offers? So the architecture of Snowflake is a combination of shared disk architecture and shared nothing architecture. So it's a hybrid, we can say. It provides benefits of both shared nothing as well as shared disk. So let us look at what exactly shared disk architecture and shared nothing means. Then we would be able to appreciate the beauty of the Snowflake architecture, why that hybrid is giving us so much of benefit. So first of all, what is a shared disk architecture? So initially there were architectures which were known as shared disk architectures, where each node shares the disk and has its own memory and CPU. So it's still a distributed system, a type of a distributed system where you have multiple nodes connected via a network interconnection. But these nodes, as the name says, shared disk architecture, all of these nodes have their own CPU RAM, but they are sharing a disk. And this was a very commonly used distributed architecture. Many of the databases used to use this architecture. The benefit of this architecture is that the read-write operations are simpler because it's not a distributed read or write setup. Essentially, your data is actually located at a central space, or the disk is shared basically. So consistency issues are minimized. Read-write operations are more efficient. But then it comes with its own share of challenges. For example, when we are talking about such kind of a distributed setup where the disk is shared between multiple nodes, there will be issues of distributed locking and two-phase commits. So that makes this whole architecture a bit complex. But this is what a shared disk architecture is in a nutshell. Now coming to the shared nothing architecture, which means, as the name suggests, shared nothing, meaning every node can act independently. They have their own CPU, own RAM and own disk. They are obviously connected by a network interconnection. It's a distributed architecture again, just like shared disk, but the difference is we are not sharing disks anymore. It is a shared nothing architecture. The nodes have their own RAM, CPU and disk. So they are pretty much self-sufficient because they have everything of their own. Now the data, the flip side of having this kind of an architecture, why this architecture came into place? Because shared disk architecture had limitations or complexity of distributed locking and those things. That is why shared nothing came into picture. But here the data had to be shuffled between nodes, which adds to the overhead. So Hadoop kind of a systems where we saw that Hadoop had a distributed file system, but every node has its own disk and CPU and RAM. Now that means that the data needs to be definitely shuffled between the nodes because it's not shared. So that is a big overhead in terms of performance. The more the data is there to be shuffled, the more will be a hit on the performance. That is where we always keep talking about optimizing the amount of data shuffle when we are talking about distributed systems or shared nothing architectures. Also, one of the other thing is that the storage and compute here are tied. So you are actually scaling together the storage and compute. But if you look at architectures of today, the way distributed architectures are, it is going towards a decoupled storage and compute. Now that is the difference between a shared disk and a shared nothing. When it comes to Snowflake, it is a hybrid or a combination of both shared disk and shared nothing, and it actually takes best of both the worlds to bring on that hybrid architecture. Typically, if you look at component level or look at the layers that Snowflake has, it actually has 3 layers and they are decoupled from each other. First layer is the database storage. This is the actual storage layer where data is getting stored. Then there is a query processing layer. So your storage and compute here are decoupled. They do not scale together, and that gives a major advantage in terms of scaling both of them independently based on need. So there is a database storage layer, there is a query processing layer, and there is a very important concept that Snowflake talks about, which is virtual warehouses, which means based on your need, you would spin up virtual warehouses which will read data from the database storage. Now you can have different virtual warehouses spinned up, and that will give you an advantage of deciding based on your need, deciding how big your virtual warehouse should be. Should it be small? Should it be medium? Should it be large? How it should be? And that can vary from need to need and user to user. So you can typically in a scenario, you will have a database storage or all data stored. And then if you have like 3 or 4 user personas which have different needs, I can have different virtual warehouses which are spinned up independent of each other. They can do their job, either stay there or we can terminate that virtual warehouse. So it's very easy to spin up a virtual warehouse, do the job and then spin it down. And also look at the capacity or the how we are creating that virtual warehouse will depend on our need. So it's a completely decoupled storage and compute. And the third layer which comes into picture is the cloud services layer. This is the layer, practically these are all services that are managing the underlying query processing and database storage and different kinds of services, security, metadata, optimization of the query, infrastructure management. All of these are as a service offered in the cloud services layer. And this layer controls our query processing and the database storage layer. So these are the very high level 3 layers that Snowflake has, and it's a hybrid structure. If you look at it, it's a shared disk because data is getting stored on a database storage which is shared across the virtual warehouses, and it is a shared nothing also because you here have a separate query processing and database storage kind of in a decoupled manner. Now if we drill down a bit or double click onto the 3 components that we saw, we will see that we have again the data storage layer are nothing but the data storages which can be on any of the clouds, because Snowflake is offered as a software as a service on all the prominent clouds, AWS, Google Cloud and Azure. So that's the bottom layer. Middle layer are actually virtual warehouses, and if you see, the virtual warehouses have different capacity, meaning the way they have been launched is in a different manner based on the need. So multiple warehouses with their own caches, and on top you have all of those services and a metadata storage layer and a cache which is actually interacting optimizing the query that you fire. There is a transaction manager which manages the transaction, because Snowflake supports ACID transactions. Security is also handled and they interact with the bottom two layers. That's how the Snowflake architecture looks like, or that's how the components look like. Now let us move on to what kind of features does Snowflake provide. There are tons of features that it provides, but I have just listed down ones which are like really good to talk about. But if you go into detail, there are many more features that Snowflake gives. So first thing is it supports ANSI SQL. So people who are comfortable writing SQL queries, have been writing SQL for long, can actually write SQLs here and access the data. There is a time travel feature. Now this is one of the USPs of Snowflake, and it comes very handy. Time travel means it allows us to store previous versions of our database, table or schema. We are snapshotting and storing those versions, so we can time travel back and forth. It's a version controlled database schema or table. Then on the storage cost, it's a daily average size of compressed rather than uncompressed data. So it actually, the cost is on the compressed data, which makes our cost very, very low. Then there are caches. So when we rerun a query, if the query has already been run, the result is getting cached for 24 hours and then it is purged. So in that 24 hours, if there is a Snowflake query that runs again, it can actually fetch from the cache. Okay, those queries can actually be cached or persisted, but Snowflake maintains a cache, and that really boosts performance because you don't have to fire the query, create the query, create the execution plan, optimize, and again rerun. It fetches from the cache. Then there is one more feature which is used a lot, is data sharing. So Snowflake Share can be used if you want to share data across multiple Snowflake accounts. This comes handy in terms of data sharing. And virtual warehouse, yes, we spoke about it. That is the core of the query processing that Snowflake has. It's a MPP compute cluster of multiple compute nodes allocated by Snowflake from a cloud provider. So it's just like you are spinning up a cluster of nodes to do your processing. That's virtual warehouse, and you can select what is the configuration of your virtual warehouse based on need. Another important characteristics or the feature provided by Snowflake is ACID transactions. It's very important when people want to do data warehousing, implement data warehousing kind of scenarios. Definitely there is a need for ACID transaction. And there is a cloud service of transaction manager within Snowflake, the cloud services component, which manages your transactions. So you have flexibility to have ACID properties. The data access is optimized because it has optimized the semi-structured data storage and processing very well. Some of the other features which are there are called zero copy clone. Now what is a zero copy clone? You can clone your source without actually a copy. Means there is a database or a source that you want to clone. If you clone it, it's like a point in time snapshot. It's not a copy, so there is no copy operation. We are talking about big data, so there are petabytes of data. I don't want to really copy and make a replica. So this is more about creating a point in time snapshot of the original and using that. And you can do changes to this clone. It's not like a read only. Snowflake also provides streaming capabilities. So there is something called Snowpipe, which is a serverless streaming. And it can actually stream data from S3, Azure, Blob, etc. So it comes handy when you want to implement use cases which involve streaming. Typically, we have seen that in data warehouses, we had static partitions or partitions getting created. Here, there is a concept of micro partitions which are getting created on the fly by Snowflake. And these are actually contiguous units of storage. So in terms of performance, this will be much more efficient when the storage is in a contiguous format. Security, of course, it provides security at rest and in motion, and it is supported, like I said, by all major cloud vendors. So you can have Snowflake from AWS, Azure, GCP, all of them, use it as a software as a service. So these are in a nutshell all the Snowflake features which are relevant or I wanted to talk about. If you drill deeper, there are many other features which typically a data warehouse would provide or a big data analytics system would provide. So this was a very quick sharp snapshot of what Snowflake is, what is the architecture, what are the features and benefits. I hope this video helps. Going forward, we will also do a deep dive on the Snowflake architecture, and then we will go into details of each of the 3 layers that we today saw. So thank you everyone for watching this video. Please like, share and subscribe for more interesting videos. Thank you.